And we are live.
Awesome. Hello, guys. आज का session of today will be very fabulous, very fantastic session. We will be learning how exactly recommendation system works. So if you have any positive or negative thing that you have seen, the jokes kind of thing. There was a joke I will even show in the middle of the lecture. There was a meme some time back that I ordered a stool, and I got recommendation for a fan and a rope. I got recommendation of let it done. I think my green screen is having some issue. Not a better. Hello Ritik, hello Pavan, hello Aryan. Aryan Tripathi bhai, how are you? Doing fine? Super energetic? Yeah, but Josh, the energy everybody. Bal hawa mein, yes, yes. My hairs are flying. Anybody made anything from the session of yesterday? When we made DLib system and facial expressions and these things. So any of you created that, replicated the code or made anything of your own, or it was just just done with the session and like moving forward with आज क्या होने वाला what is today, everything of yesterday कल था आज है, yesterday is yesterday is past, now it is gone. We don't care now. Whatever was yesterday was on yesterday, whatever is today is now today. No, don't be like that. Okay, so keep the things that we did in the past in mind so that we have better understanding what is coming up. That is very important. That energy is very important, right? So yeah. So I'm Devanshu saying I did something. So what you did, would you like to share? Yeah, we'll share. Okay, good. Shoro is saying I'm working on it. Pawan is saying they are how to install DLib on Windows. So Pawan, what is the problem that you are facing? A lot of people installed DLib on your on the system yesterday. So what you guys can do is that you can try some content, and if you do not able to do that, try to put it on Discord, and some of you might help each other so that it is much more convenient for others to install. Generally, the important thing is the compiler. The C++ compiler is the common issue that approximately every one of you face when you install DLib. So if you are in Linux or Mac, CMake. Probably in Windows also you might need CMake, but in addition to that, you might need Visual Studio C++. So install these kind of thing, and after that you will be fine to move forward, right? So just take care of these things, and it will be good. So what other problems? Uh, Parsha is saying that I'm trying to print name with mood. Okay, that is good. Okay, so that is fine. So we have done two things. But we have done mood and we have done face recognition. So one thing can be that, and another thing that we even I'm thinking of making as a playlist. Maybe in future, maybe soon. I haven't planned that yet, but one thing is that with the help of earlier we did Harry Potter cloaking cloth, right? But for that we need a cloth, or maybe especially green cloth, because that will provide us better output. But what if we could think of a posture, we could generate the posture figure, we could generate, okay, so this is the area where this person is, and we could just hide that much part. Okay, and we could also trigger that, if you want facial recognition in that, you can say that, okay, I will spatially hide this person and nobody else. Okay, so wherever this person is, I will hide whole of its body, and I will not hide anyone else. Okay, and in even for that you can put a trigger that, especially if this person make this sign, then I will hide him, and if this person make that sign, I will unhide him. Okay, I will show him back. So this kind of project can be a very awesome project, right? So you'll be like, you're making some sign like this, and you will be invisible, and after that you can make sign, and again you can. Would you guys like a playlist from this kind of project? How much of you will be interested in that, and would you like this kind of project live or pre-recorded in terms of playlist? Isn't it interesting, energetic, enthusiastic, so fabulous? How many of you are interested in contributing with me in this project? So what we can do is we can create you know uh, maybe on a GitHub project we can do that, and additionally you guys can contribute along with me in this project. Okay, so that will be good. We can do that maybe live, or we can do that. Okay, so awesome. So what we can do is that we can start with the code itself, and after the whole project is done, when we see that, okay, so this will be the good process to move forward with that. So then we will create the live session process after that. Okay, after the whole project is done complete. Okay, can a session be organized in such a way, uh, which like Instagram live, where we can interact live, share? Okay. So what we can do is that when we stream on this StreamYard, we can additionally stream on Instagram. So that is a facility that StreamYard provide to parallel stream on multiple platforms. We can do that, but I'm not sure if that will be a good idea, because Instagram stream, Kunal, Instagram stream are suggested to be of this long, 1 hour or 2 hours.
No, I'm not sure. Never used
Never used.
Instagram.
Okay, so I haven't
Like,
used that either. So some of you guys can suggest if that will be a suggested thing to do.
yeah, there's a theory that people who don't use Instagram that much are happier. So I'm trying that currently.
I think that is for a lot of social platforms, because social platforms have a lot of anxiety associated with them, because we generally tend to associate our happiness with what other people are associating their happiness with. Like even on LinkedIn, people put a lot of things like, I'm doing this, I'm doing that, but like even for machine learning and these kind of things, people put a lot of things, but generally even they are not sure if they are doing it right or not, but they try to put it because others are putting it. Okay, so it is very important to understand what exactly you are doing and what you are putting, because when you try to fake things, that is that's you as well. Okay, so you're not just faking for others, you are faking for yourself as well, and that will not really be good for you in the long term. You'll be like, okay, so I don't really feel like what I'm like I'm a split personality, I have two faces. This kind of thing will be in your head for a long period of time, and that is not a good thing to have about good thoughts for yourself, right? That is not a way to go. Yeah, so Ganesh, when I said that, Instagram Live, so I didn't say that YouTube live will not be there. Instagram live would be like an additional stream that will be just passing on. Okay, it will not be like it will not be on, yeah, YouTube. Okay, so yeah, so that's fine. Now it's 7:10. We should start with our session today. So Kunal, take it away. With your announcement for today.
So hello everyone. Today we'll be starting with our second machine learning algorithm, which is K-means, and we'll be seeing what clustering is and how it helps us in recommendation systems. Like when you buy something, it also recommends you to buy something else on Amazon and other things. So how this grouping of things happen, and yeah, that's about today's webinar. And let's get started without further ado because we're way past time. And yeah, Manish Bhaiya.
So guys, let me just share my screen. Give me 1 minute for that. Note. I thought I opened it, but somehow I closed it again. Yeah. So new section, and that is session 8. So, Kunal, please share my screen. Sarthak is saying, check out my comment on your pendrive comment tweet. I'm Adrex Chan. Special name. Okay, so let's start with our session today. Draw. Yeah, it's good. Now we are starting with our intro. Okay. So today we'll be starting with K-means. Okay, and K-means is clustering. And how exactly clustering is different from classification. Okay, clustering is different from classification. Okay, how exactly? Because classification is about classifying. It is about classifying that something belongs to this class or that class, but for that you need class. Okay, you will need class to classify. For classification you need class, but for clustering those initial class doesn't exist. Okay, those initial class doesn't exist. You are additionally putting up that you should have these things. Okay, you're additionally putting up that. Okay, so for classification you need classes, but for clustering you're just clustering up the things which exist but do not have a label associated with them. Okay, so you have X but no Y. Okay, Y and Y, Y is the label. Okay, so there is no label associated. So that is a classification. You understand this much? Okay, so how exactly we can put that? Okay, so if exactly I say that on Amazon there are a lot of products, and maybe we are talking about product based on this thing. So what is the price of the thing and what is the value or your usability? Okay, the usability. Use it just for a second. Usability. Okay, so the price and the usability. And I might say that there are some items like this and this and this and this. Okay, so there can be some product like this and this. Okay, so if we talk about these things, then we say that I want to divide these items into multiple clusters, and I want that in each cluster there should be some items that we can consume. Okay, there should be some item in this, there should be some item in this. Okay, so we want some different clusters. So if I say that I want to divide all this content into 2 clusters, so how exactly I divide that in particular case? So maybe I can say that, okay, so this is a cluster and this is a cluster. Okay, so we can say that. So I'm not saying that. Okay, so there is one question from Khushbu. Clustering also have classes. So clustering do not initially have a class on its own, but we can provide those classes. So your algorithm will decide that what all should stick together. Okay, so what we'll be doing together is k-means. So k-means will have its own way of deciding what should stay together. What is the minimum way, what is the way of representing the minimum loss. So there always the loss function related with these kind of things. So we'll be representing how exactly we calculate loss for this thing. So we'll be reducing the loss, and loss in this case can be anything. Okay, so we just have to reduce it to exactly fit to the definition of the that particular algorithm. So when we say that we want to do this thing with this particular project, so we want to do that kind of classification for this. Okay, so if we say that we want to reduce the distance traveled. Okay, like we have some cluster center. If I say that we have two cluster centers, one is this one and one is this one, and we want to reduce the distance traveled. So it's more like that. If I say that each point should have a associated cluster center, and we want to provide that kind of value. Like we have this cluster center and these points associated with this cluster center, then this value plus this value, these distances, some of these distances plus some of these distances should be minimum after generating these cluster centers. Do you understand this much? ये बात सबको सही लग रही है? Okay. So if you guys are able to understand this thing, that this is the way we divide our clusters in this particular fashion, so then we can move forward after this. Okay, so this is the way we are saying that. Okay, so this is the way you are providing our clusters, and we can use the same concept for saying that. Okay, we don't want two clusters, maybe we want three cluster or four clusters. We want to create more clusters. Okay, so for that, what we can say is that, okay, we want four clusters. This is a cluster, this is a cluster, this is a cluster, this is a cluster. We can totally say that. There's no problem in that. Okay, and if we do not specifically go for k-means, then even what we can say that, because we are dividing the classes, so we can say that this is a cluster and this is a cluster. Sorry, choose red. So this is the cluster. Okay, so this is totally fine way of saying that. Okay, one cluster is this and second cluster is this, because a cluster do not have to be exactly connected as a smaller chunk for this kind of structure, because what exactly you are doing is that you are providing the classes to the chunks. Okay, so you are providing classes to the chunks, so those classes, or everyone belonging to the same class is creating a cluster, and cluster do not have to be connected as a whole chunk. Okay, they can be like separated like this thing. Like we have these two red here, so collectively they can be called a complete cluster. That is not a problem now. Okay. Okay, so there's one question from Sayom, sorry, Sarthak. Cluster will be made from our test data. No, there are a lot of time you even have the training data, or you can say that in this particular case, in case of clustering, there is no difference between training and testing. There is no difference. Why? Because training or testing, everything is just creating the cluster itself. So how can you really separate what is training and what is testing? Okay, it is complete one thing. There is only one process that you can follow for creating the clusters. You do not have training and testing separately, because when you do not have why, how will you generate a predictive model where you can later on check if it is working perfectly fine or not? Yeah, so clustering is a unsupervised learning, because we do not have a why. Because we do not have why, we do not have label, so that it can be called unsupervised learning. Make sense to everybody? सबको सही लग रही है बात? Okay, awesome. Okay, so if this much makes sense to everybody, we can move forward. And we can say now, yeah, so we can say now that, okay, so we will go for a problem that we even discussed in the very first session. So that is pizza problem. So So this pizza problem is that initially you have these people, and what we can say is that we have multiple such chunks. Okay, and now what we want is we want that there should be one class that divide whole of this data. Okay, there should be one class that divide whole of this data. But obviously, if you say that there should be only one class, what we can specifically say that this is the class, then this whole data will be a single chunk. Okay, this whole data will be a single chunk. We are not really dividing, and specifically if we are not dividing, then whole content would like to stick together. Okay, and we can say that okay, if we really want to minimize the distance traveled, then what we can simply say that okay, put it in the centroid. If you even put it somewhere else, if you put instead of this you put here, but because everybody will go for this one only, because of that, everybody will shift to this one, and eventually this center will relocate to this location. Okay, so eventually it will happen automatically. You do not have to be very curious for it to get it to centroid. You just have to follow the procedure. Okay, so if this is happening, then we were there for the if we had two, then what we will do. Okay, initially what when we did it last time, what we did for this whole process is that we only created three. So by that way, you will be much more comfortable about what we are doing right now, because you are already comfortable with that example. That if we had only one, we put it in the centroid. If we have two, then we put one in the middle of these two and one on this. Okay, and why that this was happening, because in this case, what is happening that this one is on the center, and even if you didn't did that in the first go, you place second one here, then what is happening is that this cluster, or maybe you can say this cluster, is not getting benefit from this one. Okay, because these two are not providing the benefit. If this person can go here, this person can go here, so these two are providing similar benefit, and because of that we can say that okay, so it is not needed here, but if we can move this one along the other dimension, like here. Okay, so like we put this one here, so it is providing much better benefit to this area, these items. So this way we can say that okay, this is the more beneficial state that we can plan. Okay, and if we can plan this one will provide us much better benefit, and this way this is much more stable state, and we would like to go further. Okay, if we have three, then we can simply do this one and this one, and now we are stable. If we go for four, then the point is that should we keep the fourth one here? But this doesn't make sense. If we put the fourth item here, it is not really providing us any benefit. So we would like to shift it to some other location, maybe just inside this one, or any of these point of itself. Okay, the question from Sarthak is how cluster is different. K means is like KNN, not getting. Okay, K means is not like KNN, because KNN you initially had the classes for each and every item of in such state. Right now you do not have. It is more like you have to like in Amazon, the company have to decide that okay, so when I was giving the Amazon example, it was like okay, there are some item here, some item here, some item here. So there is division about costly. I think it is made upstairs. Yeah, upside. Yeah. So there is this is the price list. This is the usability list. So there would be some items which are highly usable. Okay. So if a person buy costly thing and less usable thing, they belong to this cluster. If a person buy pricey things but more usable thing, they belong to this cluster. If a person buy less pricey thing but less usable thing, they lie in this cluster. If a person buy cheap things with more usability, they lie in this cluster. And generally people have their specific way of living, so because of that you can even on the base of their expenditure you can tell their expenditure and their understanding of usability. You can tell that what kind of product they will be interested in. Okay, so this is a way you can create these kind of recommendations. Okay, So you are initially creating the clusters which can eventually provide you recommendation procedure. Okay, do you understand this thing, guys? This much is comfortable for everybody? Okay. So if this is comfortable, we can move forward and understand this thing. Okay. So how exactly this is different from KNN? That in KNN you already had classification, and there came a new point, and now you had to tell that to which class this item will belong. But right now we do not have any initial Y. So what you are doing is that you are creating Y for them. Okay, so if we take example, like let me create some data for you so that you understand this thing. So let me launch our notebook. Okay, so question, there is no exact way of getting to the accuracy in this particular fashion. So what we can simply say, what will happen in this case is, just let me remove this file. Okay, so what will happen in this case is that we do not have any specific value to the accuracy, but we have a value for the loss. So what we can say is that we have to reduce the loss, and the way you have created your cluster center, if they are providing a loss which cannot be defeated by any other thing, then you have provided the best loss, and it is having a better accuracy than the other one. Okay, but it is always about what exactly algorithm you are putting. You cannot say that the loss of k-means will be better from hierarchical clustering, because hierarchical clustering is providing different loss, and k-means is providing different loss. Okay, so you can simply say that okay, you are going for k-means algorithm, this is the way you calculate loss for it. You have to just shift your point so that you provide the best loss. Okay, so now we will go with session 8. Good. Okay. What happened? Oh,
Let me show something. 1 second.
Parcham, I'm not talking about log laws. Log laws is a very separate thing. You do not have to go for that. Yeah, we will discuss log laws and logistic regression. Don't worry about it.
There are some doubts. 1 second. Let me just share something. So this is what we mean. Like I just created 4 centers. We have done make blobs before. So I'm saying that I need 1,000 points and I need 4 centers. Okay. So here I have 4 centers, and here it's just plotted this for me. But what if I just in the k-means, I say that I need 4 clusters. In the fit, I only provide x. I do not provide any y. Okay. So after that, it's going to generate this y for me. This y, it's going to generate this for me after the model is trained. So here it automatically figured out which points lie in which cluster. So you can see this is sort of like similar. If I say that, okay, these are the data sets, I need like, let's say 3 clusters. So it's going to be like, okay, now it's going to be 3 clusters. So now you can see only 3 colors. If I say that, okay, this is the data set X, notice I have not provided Y over here. I'm just saying that, okay, only one color needs to be, this is the data given to you, means this is the data given to you. This is the data given to you. Distribute this entire data in just one color. So in just one color, it's going to be just one color. Distribute this in, let's say, 2 colors. So now it's in 2 colors. Distribute this in, let's say, 6 colors. Now it's in 6 colors. So this is what is meant by k-means, and how this is different than KNN, because in KNN we are doing model.fit x comma y. Here I'm not doing y. So KNN was that this was given to you, And if a separate point was given to you, you need to figure out which cluster that point belongs to. But in this case, you don't know what the clusters are, and you need to make those clusters. You need to identify those clusters. And identifying the clusters is done by k-means. So you can see I have not provided y over here. Doing some sort of algorithm, it's figuring out the clusters itself. If I just change this, let's say centers 5. Now it has 5 centers. And if I do the centers 5 here also, you can see this is same as this. This is 5 clusters. This is also 5 clusters. So that's what k means is.
Yeah. As simple as that. Okay, so now if you understand this thing, there's one question, how do you decide the value of k? So you just want to minimize the loss, and you generally try with incremental value of k, and you eventually find out that this is the value where the loss is not now decaying very often. So we will go with that. I will show you how exactly we are getting the value of x, the value of k in this particular case. Okay, so you don't have to worry about it. You will by the end of this session you will understand how exactly we find the value of k. Okay, so don't worry about that. So now we are in session 8, and I create this file for you, and exactly in the very beginning we'll be doing the same code, what exactly Kunal has shown you right now. So we'll be doing import numpy as np, import pandas as these things. Import numpy as np, import pandas as ed, import matplot dot plot as plt. Okay. Import pandas as pd, import get. Yeah. Okay, so we have imported, and now we want to create some values. Okay, so we can create values for this, the data for this thing by two ways. Okay, so we could use just numpy, or we could use, an additional sklearn tool for that. So we can say that from sklearn, and sklearn from datasets, we are importing make blobs. Okay, this make blob help you creating blobs. Okay, so if we say what exactly make blob is doing, make blobs is providing this data where you are saying, okay, so I want these many samples, so these many we can say feature points. So you are saying that you want 100 feature points with 2 features, and how many centers you want. Okay, so if I say I want by default 3 centers, okay, so these will be 3 centers where we'll be having some points, and corresponding to that we can additionally say random state 42. That is a general trend that we do, and you will be getting the x and y. Okay, so you will be saying that okay, so we are getting both x and y, but you said that in case of unsupervised we use only x. Okay, so but what if I say that I ignore this y, I do not need this y, I just simply have to receive it, because make blobs return to values, and if make blob is returning to values, I obviously have to receive 2 values. Okay, so because of that we are having x and underscore, but that is not mandatory. We could simply say x comma underscore or whatever, but we have to receive 2 values. And if we have received the values, then what we have to now do is we can simply represent what exactly this x is. So if I simply show you, in case of plotting, then this is the feature 1 and this is the feature 2, or you can say this is the feature 0 and this is the feature 1. And when we plot scatter data, if even if I want something better to show this whole value, and we say that this is not, we are not representing this using matplot, we want something better, we can say that we are using SNS for that. So you can say import cbond as SNS, and now we can say from SNS dot scatter plot we want what? We want x and y. Okay, so we want x and y. So For us the x-axis is what? The feature 0, x all values feature 0, and y-axis we have x all values feature 1. This is the scatter plot we got. Okay, this is the scatter plot. So we have three centers, we have the values associated with them. Okay, so you could say that if we wanted to represent the color, if we wanted to represent the hue, we could simply say that that is underscore or y, whatever we had in this case. What we had. If we had received it as y, we could simply say that okay, this is our y, and now it is representing okay, 0 is this value and 1 is this value and 2 is this value. Very specifically it is representing, but we are saying that we will be only using x, we will not be using y. Okay, because we can assume, even if we have y, we can assume that we do not have y, and if we assume that we do not have y, we can simply say that we only have this data. Okay, so we do not have any class associated, we just have this data. This whole data is just clumsy and just represented in its fashion. Okay, now if we have this data and we want to create classes by ourselves, so what we can do is that we can use k-means as as an algorithm. Okay, and as we have already specified what exactly k-means is. K-means is simply saying that we want to minimize the loss, and the loss is the total distance traveled from the cluster center. How exactly we implement that, we will see soon enough. But what exactly I'm saying is that k-means by default just say that we want to minimize the loss, and loss is the total distance traveled from the points to the cluster centers. Okay, the corresponding cluster centers, we can say. Okay, so if we have this structure and we can simply import our sklearn k-means, so we can say that from sklearn dot it is for clusters, so it is in cluster import k-means, and in this we can say that we are creating a model for k-means. Just 1 second. K-means, and in k-means you have different parameters that you can pass. Okay, the parameter it is telling us to use is just 1 second, that we have this much number of clusters, then init value and an init. So I will just showcase what exactly these values are. So n clusters is the number of clusters that you want to create, and in it how many number of times you want to start from the random values and you want to minimize the loss. Okay, and max iteration is that in every iteration how many number of times you want to take the steps to want to reach the eventual position. Okay, so this is the difference, and then you have tolerance until you have this. This is the value, the number of the change that you are getting. If it is greater than this, only you change. If it is lesser than this value, then you just follow it. You get out of the loop. Okay. So if I say that I will, we will even cover it in much more depth when we provide the custom implementation. But don't worry about it. If I simply say that okay, n number of cluster that we want to create, n clusters is equal to 2. Okay, and now we say that model.fit. So we use fit function for creating the output. So we say model.fit, and now this model have some labels, model.labels, and we can say that this is our y generated. This is our y generated. This is the y that is being created. These are the outputs or classes that you can see that you are getting out of this data. Okay, and if you want to show our data corresponding to this one, like we want to say that now we have this y gen with us, and this is the value that we are creating. Okay, so these two belong to the same class and this one belong to the same class. Okay, and if we additionally want to reflect our cluster centers, it is also giving us the cluster centers, and these cluster centers are also in the model.cluster centers. These are 2 points which are cluster centers provided by this algorithm. So let me just also put these cluster center so that you can really showcase where exactly which cluster is the cluster center, specifically location. You can say the pizza places from where you are ordering your food. Okay, so how exactly it is happening. So that we will take a look at when we exactly put up the code. So don't worry about that. Okay, so when we're saying that it is the cluster center and we want to put it, so we can simply put them by putting up a loop for center in model.cluster centers. Every center we can say that plt.scatter, I want to put, for this center we have value 0, and for this center we have value 1. And let me put the size of the point that we will be putting here is 60 or something like that. And let me put this, so just 1 second, that s is equal to. Okay, so now what you can see is obviously the color is not matching because that is not something that we provided by ourselves. But what you can see is that this cluster have cluster center here and this cluster have cluster center here. If we increase the value to the number of clusters, like we say that number of clusters we have now is not 2, it's 3. So now we have this division. So this is the cluster center, this is the cluster center, and this is the cluster center. This is the way we are doing it. And when we said that if we have value to be 4, then the fourth one will not be in the center, it will be dividing the data of some data. Okay, so here we can say that these are the two values that we are having here, and it is dividing the content from here itself. So now it raised the question, the first question is that how exactly this voting is happening. So let me just provide the concept of this algorithm again. So we want to minimize we want to minimize the distance traveled. So every time, whenever you get the vote, okay. So when we say when we represent this in format of notebook, so what we can simply say that every time we have the vote, okay. So we have these many people here, this many people here, and this many people here. So we have our initial cluster center here and here, and people are voting now. So this person have to vote. So to which pizza center this person should vote? What is the suggestion? To which center this person should vote? I will say that it should vote for the center nearest to its location, right? Where it will have the benefit of quick delivery. If you are living in Gurgaon and you have to decide, even if you are said that you can decide from whichever Pizza Hut, generally you will order from the Pizza Hut which is nearest to you, because you will have the benefit of easy delivery and fast delivery, you can say, right? इसमें किसी को कोई दुख तो नहीं? This much is comfortable, right? If you have option for delivery from any Pizza Hut, and you understand that every Pizza Hut have similar quality of delivery, you will order from the Pizza Hut which can provide you the quickest way of delivery. Make sense? Okay, so every person will order from the delivery location where it is closest. So everyone will try to find out if this one is closer or this one is closer, and after deciding the closest of the center, it will put a vote to that center. This will put the vote, this will put the vote here, 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 and maybe 1 or 2 is coming here, and this one is going there. Then here, this, and a bit of here, but the most of the here is going this, and this. Okay. So what now? Can we say that after this much is done, if they could relocate, if these cluster centers could relocate for providing the delivery, they should have, because that way they will, optimize their further redistribution. Okay. So by that, we can simply say that if we want to reduce the distance traveled for providing the items to these, we want to generate the average distance traveled per location, and we want to minimize that. And what we can simply say is that if we can provide the mean of these cluster locations, this location, this location, this location, if we can provide the mean for that, the new location will be the better location as compared to this one. Okay, that new location will be the best according to the current distribution. Okay, so now this cluster center will move from here to the new location. Okay, So maybe this new location is a bit here. This new location is a bit here, and this new location is a bit up. Okay, so now what will happen after this distribution? Now, if we repeat the whole process, what will happen for the second voting? That all of these people will vote for here, and all of these above people will vote for the above one. And now what will happen? This one will now be inside this, and this one will be now in the very center of these all items. Okay, like what it happened uh, in the way we distributed. Okay, so this way, this one will be here. Okay, do you understand this thing? So there's one question from Sarthak that can we call so k-means as brute force? So k-means is not very optimized approach for doing things, but it is not exactly brute force because we are not exactly going for very random approach. It is a bit uh, you can say that all of the clustering is to some level some kind of brute force because clustering is generally about moving with all the values, but it is not very optimized approach, I will say, but it is not exactly a brute force approach. Okay, so you cannot call k-means as a brute force. Okay, but it is good. It is it provides some real significance to the value it's generating. Okay, so if we move with that and just 1 second, let me put charging my phone. Okay, so what if we already have generated this data? So we have already generated this data, and we already have this x, this x. Okay, we have this data, and now I want to create class, and this classes are. Should I do this in the same notebook or different? Maybe same, doesn't matter. Custom k-means. Okay, this is my custom k-means. Obviously, we will need a gender init function, gender init, and in this gender init we have self, and then we will have n clusters, number of clusters we want to create, and that by default maybe we can keep it to 3, and self dot n clusters is equal to n clusters. That is fine. We have this value, and now the second value that we have to create is fit. Okay, so we have to create a fit function, and for that we also add self, and we additionally just pass x. Okay, so even though we could pass more parameters in it and fit, but we are not passing. We are just saying that we have to create this much of cluster from this data, and we are just passing x to create the fit for that. Okay, so that should be fine for everybody. I don't think that anybody have any doubt on this thing because we are just passing the fit value. Like there is a k-means k-means code that we did just above here. Like we are creating similar to that. We are creating our own k-means, and that begin from here. We create a fit function, and in this fit function, what we simply say is that we want to create some clusters. But how do we create clusters here? Okay, for that we need a separate class. We need a separate class called cluster. This cluster class, every cluster have a center point, and they have some point associated to that cluster. So we can simply say that in this one as well, we will have a gender init function, and in this gender init we have some uh, the location of center. Okay, we will have the center that somebody will pass to us, and I think when we create that should be it. There should be only this point where is the initial center. So we can simply say that self. Sorry, there was a mistake in this one. That's self, not self. Self dot center is equal to the center of this cluster, and then we have self dot points, that the voters we have for this particular pizza center. So you can say that self dot points is a default empty list we have for this one, and then we can have separate function associated, but even we can leave it as well. If you want to do that, we can leave it as well. Okay, so now we have this cluster center. There's a question from Percham. We can choose. Okay, it's not a question. What is happening in my data is, what will happen if my data is non-linear? We do not have any linear data here. Yeah? Okay, don't worry. Just take a look here. So we have this much like center and the points, and now we can say we have different functions as well. Let me just not put those functions for now. We can put those functions later on. So when we say that we want to create a fit, initially we want to create clusters with this value. Okay, so what we can simply say that we want to create some initial clusters, and we can say that these are the clusters that we have created, clusters, and initially this list is empty, and we can say that for I in range self.n clusters. These are the number of clusters that we want to create. We can say that we will choose a single item, okay, by using the random library, or we can just use this import here itself, import random. Okay, by using this random library, we can say that we will create a new cluster named after this and cluster, and random dot choice from the X. We have chosen a random item from X, and we created as a we pass this value as the center of this new cluster we created, and we save it as cluster dot clusters dot append this new cluster. Okay. Okay. So I'm not creating a real fit right now. I'm just simply saying that, okay, we have created these clusters, and now after creation of this cluster, I will simply respond back. Okay, I will just simply say that I have returned, these cluster centers that we have created, and for that we can simply say that for if we want to create cluster centers, that will be like cluster centers, and that is an list. So we have this list, and or we can say this list comprehension center, or cluster dot center for center for cluster in clusters. Okay, and we can pass this value to the self dot cluster, these this value that we generated here, like model cluster centers. Okay, so if we create the simple code, we have this cluster location point, and then we create this much code when we are simply saying that we are using the same data. We are like we have this k-means function, then we have this y generated, and then we go for this code. Okay, like we will not be putting up the hue, we will be simply going with this one after this code. So we can simply say that we have this code with our custom code. Okay, we'll be using our custom k-means, and after that we fit, and after that we simply go with this. Okay, so I will not be providing the hue color because we haven't generated that, but I will be putting up this value. Okay, so now if I show this, you can simply find out that it is not really distributing anything. Okay, we are not saying that we are not generating any color or anything. We are not fitting anything. We are just simply putting up these values. Okay, we haven't optimized anything for anything. We are just so spelling is wrong. Yeah, that is fine. It is working now. Okay, so we are not really doing anything. We are simply saying that we have created the cluster and we have simply responded it back. We are not optimizing anything. We are not optimizing our loss. We are not doing any iteration. We are just saying that we created clusters from the centers and then we responded back. Okay, and you can obviously find out that this is not good. This is not generating what we wanted to generate. This is not optimizing. Okay, and now we want to optimize. We want to create a code where the loss is better than this, where we travel less to distribute these values. Okay, so for that, what we can say is that we want to do the iteration. Okay, and we for what we have to do is that we have to decide that there should be initial labels. There should be initial labels for every cluster center. Okay, for every cluster there should be some initial label. And how do we do that now? Is that we can simply say that we have some initial labels that we had. Just one second, my screen is stuck. There's a problem.
So there's a question by Aditya, why are we using custom if there are inbuilt libraries? We're just using custom because we need to know how it's working internally. Okay, obviously we're going to be using inbuilt libraries when we're working with real data in the real world, because they are much more optimized. But we're using custom because we need to also know how that code is written, how it's working internally, to get the more important. It's really important to get the gist of it. Like there's one thing about using a particular class, and other thing is like, how is that class written, how is it working internally. So that is why we're doing it.
So I'm back. Yay! So there's one question from Simir. Simar, what is better approach? Using built-in function or making from scratch? The better approach is obviously use built-in function, but to understand how exactly things are happening, we try to generate from scratch. Okay, so the thing that we are doing in this case is that we are saying that we have this labels list, and now we have to go to every point. We have to go to the every value of x to the every point, and we have to ask them to which center, to which cluster center they want to go. Okay, so we can simply say what for point in x. Okay, for we are going for every point in x, and we will simply ask them to which location they would like to go to. Okay, so what we can simply say is that okay, for point in x, good, we want to ask for the distance with the every cluster. Okay, so we can simply say that the point in x, we want the distance structure. Okay, we want the distance structure. Okay, distances, and distances for what? For cluster in clusters, her cluster say, we will be getting the distance. And how do we get the distance from a cluster? We could do, we can do it in two fashions. So either we can create a distance function here. We can simply say we will create a definition distance, and if somebody passes a point to us, we can simply say that okay, for that point, the Euclidean distance, as we even seen in case of Canon, that will be like point minus self dot center. Okay, so we will be providing like x2 minus x1, y2 minus y1. Then we will be putting up the square of both values. Okay, then we add those values, np dot sum, and then we provide the square root, np dot square root. Okay, so these are the operations that we do, and then we return them. Cool. So this is the thing we do it. Okay, so if we do this one, and after that we get the distance, then we can simply use this distance here. So we can simply say that okay, so this is the distance we want. So like distances dot append this, sorry, cluster dot distance point. Okay, good. So after this process is done, we have received the vote from everyone. Okay, so we have received the vote from everyone, from every cluster. So what is the distance? Now what we can simply say is that we want to find out the closest index, the index of the closest one, and we can simply say that this is the arc min value from this distances list. Okay, this is the index of the closest cluster, and the closest cluster is now we can say that is from list of clusters, this particular closest index, this is the closest cluster. And now what we want to do is in this closest cluster dot points, we want to append our point. We want to append our point here, and additionally, in case of labels, we want to append the index of this closest item. Okay, what is happening by this is that after this process is done and we are out, by doing this whole process, we have got exactly every point in one of the clusters. Okay, so every point is every point have decided which one is the closest cluster, and it have been added to that particular cluster. Okay, so by this we have got the voting. By this we have decided the point. Every point have got the distances. So we can say that going for each point, collecting distances from every cluster, finding closest cluster. Okay, so if this process is done, we are done with allocating every point to one of the clusters. And if this is done, we can simply say that we have a much better capability now. Okay, of what that we can simply say that we have labels associated with every cluster. So and we can simply return that when we provide the labels, we could simply say now self dot labels is equal to labels. This is one of the things which we could later use here by just 1 second, X is not oh we had to restart, so because of that we will need to rerun these points. Okay, just 1 second. Yep. Okay, good. So now this is a bit divided. Obviously we haven't provided the color here, so we can simply say that this is, sorry, not here, we can say hue is equal to self dot, sorry, not self, this is model dot labels, and now we have this thing. Okay, So this is what we have. Okay, so this is the initial distribution that it is getting, but obviously it is a good thing as compared to the previous one. But we are not, creating multiple iterations. So what we can simply say that, and we haven't even relocated our cluster centers. This one is just for appending, but after appending everything, we generally do not just go with, okay, so this is done. We also have to relocate our cluster centers. And for relocating cluster center, we can simply say that for every cluster in clusters, we have to relocate the cluster center. And what will be the relocated cluster center location? So we can simply say that cluster center will relocate to the mean of points about axis 0. Okay, because we are getting the points in a list, and we have to take the mean of those points. So we can simply say that np dot mean of the cluster dot points about axis 0. Okay, and this is the process, and this whole process that we are doing for from here to here, that will go inside a loop of iterations. We can simply say that for I in iter, or you can say I in range max iters. Okay, we can do this loop, and generally what we generally do is that you would have seen that we had, when we created this, we had this max iters in here, and we can simply add it to self dot max iters. Now max iters, not inters, iters is equal to max iters. Okay, now we have max iters here, and good. Just 1 second, we did something bad. Arrays must be of same length. What we can do is that after this one is done, so that after we are doing things right, we can simply print our clusters as well as labels. Labels are coming up fine. I think the problem is with scattering of these points. Oh, so what happened is that we have to reinitialize the list of labels every single time. Okay, so that was the problem. We have to take care of that. We every time we initialize this loop, we have to empty the list of our labels. So this one was out of the loop, so because of that we were adding up a lot of labels. We were not clearing up the old labels when we were putting up the new labels for the data. So if we do that, this one is done. Okay, so we have created this custom implementation of our kernel, so k-means. And if we want to reduce the number of clusters, it can simply happen this way. Okay, so this is the way, if you are doing this iteration. So like we have provided max iters to 10. We can even increase that it is not divided like this. Okay, and now it is gone. Okay, so we'll be getting a better answer. Okay, so this is the way you provide the custom implementations of k-means, you can say here, and this is the thing that we really wanted to discuss today. Okay, and after that we will be having a bit of more of practical discussion about recommendation system. Okay, so if you are confused about this code, you can discuss now, or we can switch our discussion to the recommendation system. What do you guys say? The session is not complete. We'll be starting with the recommendation system. You will not get the quiz link before that. Kunal, are you here?
Yeah.
Yeah. Okay. So I'll be back in a minute or two. You can take over for that. Okay.
Okay.
Yeah, sure. Thanks.
Max hitter basically means वो पूरा का पूरा max hitter means that how many times you want to repeat the same process again and again. Okay, now why is that? Why are we doing that? Well, because we are first choosing the points at random and then redistributing those points to the clusters. So these things that we do, putting that on random, we're doing this again and again by using max hitters to get better accuracy. That is just what we're doing. The code will be pushed on GitHub, so you can check that out. So in the end, we divided into two clusters, orange and blue, but how do we know that one will be in the middle? Let me just open it up. Which confusion? Which is confusing? Okay, so this is what we were doing. Let me just run this again. So this is the code for k-means. Here we have the code for cluster. Cluster just has a center, the label, and the points. So points means that which all these points lie in a particular cluster. How are we doing that? Well, first we're taking random, like random points. So we're taking random points over here, okay, as and making clusters according to that. So how many clusters you want? Let's say I want at initially it says n clusters. So if I want 3 clusters, it will take 3 points at random and append those points in the clusters array over here. And after it's what it's doing is that for max iters, means how many iterations you want this to run, means the entire thing. So that is just going to do the same thing which we mentioned, like for each cluster calculate the distance of point from that cluster, and take the top the minimum points that are closest to that particular cluster, and append those in this self.n clusters. So this is going to be one second, in this self.points. So this each cluster is itself a class. So each cluster is going to have like an array, which is a list which also contains the points that belong to that cluster. So if these all points belong to a particular cluster, then these all points will be in this list. And that is just what we're doing again and again and again and again. And regarding the error, you can see it's falling after we are doing like you know um, uh, redistributing the centers. So first time we did all the calculating the distance, then redistributing the centers, then we did that again, and how many times we did that? We did that max iter times. Okay, so max iters means that how many time you are like actually redistributing the centers. And after that, at a particular time, the centers will be at those places where there is like no more change in the distance is happening. Okay, that is why if I just plot errors, which is just the sum of distances, you can see that at random at first the distances between all these points are very high. After that, when we redistributed it, the distance became a little small, then distance became little small, then distance become little small. So you can see that the errors are like uh, first my distance was 400 something, then it became 200 something, then it became 100 something, then 109, then 102. So after a particular, after like 1 2 3 4 5, after 5 iterations, my error became stable. So that is what you can see over here, and here you have your clusters. This is the original one because c is equal to y, and this is the one that my model has created. C is equal to model.labels. Yeah, the code will be shared. Feel free to like debug it, go through it, watch the video again, and it's not that difficult.
Yeah. So yeah, so I was not looking up to do that code live with you guys in terms of the error and everything, because that would have been a bit too much. But Kunal have kind of showcased that much, and you guys can later on debug with it. So that should be fine. You should be able to understand these things. Uh, I think every doubts are resolved, or somebody having doubt.
Yeah,
Okay.
not many doubts, but you should definitely watch the video again and go through the code again. Get a
Yeah,
more.
yeah, because even though you guys are not having doubts right now, but these are not topics that you can just skim over and leave. This is something that you should have a bit of repetition kind of thing. Okay, cool. So let me share my screen. Okay. So now we'll go for recommendation system. And what exactly is recommendation system? So recommendation moves in two dimensions. So recommendation is, obviously there can be multiple, more multiple distribution, but we'll be focusing towards two kind of, filtering. So one is collaborative filtering, and second one is content-based filtering. Content-based. Okay. So what exactly is collaborative filtering? So it is more like that a lot of people have some opinion about some things. Okay. So like I like some particular movie and I like some particular other movie, and other people, may like such kind of thing. So collaborative filtering depends on that. Some people like similar kind of movies. Okay. Some people like similar kind of movies, and if I know a person that like movies just like you, I can suggest you a movie depending on what they liked. सेंस बनता है इस बात का कि कुछ लोगों को कुछ कुछ मूवीज पसंद है, कुछ लोगों को सेम मूवीज पसंद है, ठीक है. सम पीपल हैव सिमिलर मूवी प्रेफरेंस, एंड बिकॉज ऑफ दैट पर्सन, you generally do what, if you want some movie recommendation, you generally try to find a person who have similar interest as you have, and you try to ask, "ये यार नई मूवी कौन सी है ना, what is the new movie that I would haven't watched." So uh, based on that, they generally suggest, "ये देखी है, if you have watched this one or that one," and you can say, "Okay, I have watched this one, I watched this one. Okay, yeah, this one is new. I haven't watched that one. I'll watch this movie." Okay, so that is collaboration based filtering. Okay, so and the second one is content based filtering. Content based filtering is more about what exactly is the content of something. If I watch particular movies, and based on that I can have some particular location of my features. Like I generally like horror movies which are generally of 1970s or something like that, and generally have a rating in between this and that. Okay, so those are particularly my preference of watching. They haven't been generated by other people, they have been generated by the movies that I watch. Okay, it is just based on the movies I watch. It is not depending on the other features of other people. It is not depending on those kind of values. Okay. So what are the benefit of these things, and what kind of data you generally need for these kind of values? So what we can do for that is, I might I should generally show you some data for that. What we can do is recommendation system. From Let me rename this one to a in the recommendation. I will import. Let me just import these for you. And I have put two files for this recommendation project into your datasets folder. That is in Recom we have anime and rating.csv. The anime CSV have this data, the name of the anime series, genre, type, episode, and much more data. We will just load it in pandas, and we will discuss it further. Okay. Just one second. Why? Oh, stuck all that enough of it there. Okay. Okay. So we will load those files here, and I will showcase you what exactly that is. Okay. So we have a rating file. So that is pd.readcsv, and in that CSV, the datasets folder, we have recommendations, and in this we have our rating.csv file. And if I go for rating.head, let me just zoom in. Rating.head, I will show you that we have this much data. We have the ID number of person, we have user ID, we have anime ID, and we have the rating that they provided. Okay, so -1 means that this person haven't provided a rating for this particular movie. Okay, otherwise, if they have provided a rating, that is like this person to this movie, this anime is providing this person to this anime is providing this. Okay, this is the rating, and this is detail one. Detail is for another CSV, that is CS ed.read CSV. Datasets, recommendation. We have anime.csv. Let me just call it anime. So in the anime head, we will find the columns for that. So that is the name of the anime, genre, 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 type, episode, rating, and the number of members rated it. Okay, so these are the columns that this one have provided here. So what we can simply say is that we can specifically find a particular recommendation for you, depending on the genre, the type, episode, these kind of things you look for. Or we can kind of use this data. This person rated this movie for this movie for that movie for that, and based on that data we can specifically find which particular movie you might like or not. Okay, so this one is what, if we just have just the ratings, comment, put in the comment section which one is this. Is it collaborative? This rating sheet that we had, is it collaborative or content? Which one is collaborative and which one is content based? You can put in the chat section that I get the understanding of yours, that what you're thinking right now. We have two sheets right now, rating sheet and the anime sheet. Which one is for which one? Which one is for content based filtering and which one is for content based filtering? Yes. Yes, collaborative rating, and rating one is collaborative. Content is, yeah, anime. Bilkul. Everybody is doing good. You guys are fabulous people, putting up fabulous effort. Anime is content based. Anime one is the content based. Yes. Okay. So what we can do, if you have, what we can simply say is that, let me just put it much more simply. Let me just get the drama, animes corresponding to drama, or maybe supernatural. Yeah, so corresponding to drama, I will filter out all the animes which have drama associated in them, and we will use only that for creating a basic model for cluster. Okay, so that will be a simple simplistic way of representing things. Okay, so what if I if I show you that we can filter out this, we can say that we have this anime. Okay, in this anime.apply, we have to pass out a function. Okay, and corresponding to that, I will like to only select where our drama, the value of this drama is contained. Okay, where we have this section. Okay, so what we can do for this, we can say that we will create a function, we will create a def for filtering, and in this filtering we will pass a row, and In this row, we will check for genre, and if that genre contain the string drama in genre, then we can accept it, otherwise we will reject it. Okay, makes sense that we want this kind of filtering, that we will only accept a particular row which have drama in their genre. So do you like this process? We can have a filter like that. Seems okay to everyone? Okay, so if we create a filter like that, you guys can check out even different approaches for that. The simplest one is, maybe apply, or you can have even lock one about, locating. You can even get, if you don't want to go for this one, the different one. And let me not just delete this, just put it on the fold and say that, okay, we have a particular column genre, anime dot we can say anime dot genre here, and in this particular column I can even convert it into numpy dot array, sorry, np. So this is the one, and now what we can do is that we can even do a simple filter that we used to do for the different things, like if we can say we want to create the list of indices, we want drama in row genre, sorry, you can say item genre, or you can say in item for item in this, for item in our this items. So is not iterable. What happened? Item 0. Kunal, what is the issue with this comprehension?
It says float is not
Yeah,
iterable.
but
So is
we don't have any float here. This is the array, and on the individual item, it is working perfectly. Drama in item for item in items, item 0, drama in item 0, it is working fine.
can you print items again?
This item, this items is this.
Yes.
Yeah, this items is this. This is this. I think this bracket is putting some error. This should not.
Can you print item in items?
Print item in items, but we are getting the 0th item now. This one is, yeah. It is
But error नहीं आना चाहिए ना फिर.
Maybe just for this thing, we can do this. Oh, yeah. So it was an object, but when we were doing it outside, it was perfectly fine. But here it was having some issue. Okay. So this is the valves we have here. Okay, so we got these values, and after this what we can say is that now we can decide that which row have what. Okay, and if we want to use pandas, we want to use the location filter, we can say that corresponding to lock, we can say if in anime dot lock, the rows that we want are corresponding to these wells. So now just one second, this. And now these are only anime series where we have genre as there is drama in genre, because we have filter only those one because of this lock filter. Okay, so this is our we can say X. Now a complete X is this one. Okay, and on this X we even want to select particular columns, but because we have, if we go for anime dot columns, we have a lot of columns right now, and we only want some particular columns. Okay, so we want anime ID, anime name, and some particular features. Okay, and just for the sake of it, we may say that okay, we don't even want name or genre. We only want episodes, ratings, and members. Okay, so we only want these. We only decide our preference only based off these values. Okay, after this exercise. Okay, so just one second. Anime ID type episodes, yes. But let me just get this one as well, so that we have no a name somewhere, so that we can later on get the name from it. X, and then these columns. This is a X mod. Okay, cool. Okay, so we have this, and if we go for describe, we can check if we have enough of everything or not. So we do not have rating for some members, in some cases. So we will need to remove that as well, because we do not want any row which have any kind of nan values. Okay. So if we remove that as well, so for that, we should have cleaned that up, even beforehand. But if we do that even now, we can simply say that okay, so if we create a cluster based on rating and members, and we want to kind of represent it on a chart, so we can do that. So we can say that import seaborn as SNS, and we can say that SNS dot scatter plot. Our for X we have this X mod dot rating, X mod dot rating, and we have our X mod dot members. Okay, so this is kind of the distribution. Okay, and because of that, you can even say that this is not a very good data. If we have only these two values, this might not be a very good data for the very basic level of distribution. If we have only these two values, okay. But if we had because it is just because kind of a bit dependent answer, you can simply say that, because it is what we are just saying that the rating and the members associated with that, and generally people the items that have better rating have better number of members associated with that. So this is kind of thing you can simply say that okay, so this should have happened like that only. But if we could add in this x dot rating and x dot members, instead of we had x dot rating and the second value to be like if it is a if we get the type. Okay, so you can find this kind of breakage here, like ONA, music special, OVA, TV, movie. So now you can find the type of clustering, and even in any individual one, you can divide like okay, so this person like ONA based on the rating of this particular rating area. Somebody people maybe like this one. These kind of distribution can happen. You can like on the base of type and like the number of episodes that they have, or maybe yeah, so like maybe the type, and maybe if we say just a second, yeah, type. So the type is done here, movie is done, yes. We haven't divided it, otherwise we could put it in 4 genres, like number of episodes, we can use that. Ratings and episodes, yes, this is a good distribution. So these kind of graphs you can take a look at, and you can kind of find the distribution, and you can even create some kind of k-means kind of distribution in here. You can also use hierarchical clustering and this kind of distribution. Because of that, it will kind of provide you some idea how something similar is provided to you. Okay, when you go for Amazon, and you can take a look how exactly things work. So this is the way it happens. Okay, so this was the one based on, you can say, the content based filtering. How exactly if you have this thing, if we have if you watch 5 6 movies, then corresponding what we can say is that the average of features of that movie is your value. And with the help of initial clustering, we provide the clusters, and later on we can use a simple canon based search, or we can simply find out okay, you belong to this location, and then with the help of any classification algorithm, we can find out that okay, you belong to this point, this is your value, and this is the initial clustering, then to which particular location you belong to, and we can suggest you all of those movies belonging to that cluster. Okay, so that way generally movies are suggested in a recommendation system. In case of collaborative system, a very similar approach happens. The difference is that generally we create a 2D list for that, and that is similar to this one, that we provide a list of yeah, so we provide the name of people for rating and the rating that they provide. Okay, we provide these two values, the name of person, and the value. Okay, and this will be a sparse list, because not everybody will be putting a rating for everything. So this will be a sparse list. Somebody will be putting some value for something, somebody will be putting value for another thing, but this will be a sparse list. Okay, so like somebody is like putting for this particular movie, there's a particular rating. Sorry, you can say rating will be here, this will be the name of movie. Okay, for this member, for this movie, rating is 5. For this is 5, this is 5, this is 5, this is 1, this is 2, this is 3. Yeah, so it will be like people fill it like this, and now based on that we want to check what will be the rating of this particular movie for this person, this particular movie for that person. So we generate that. Okay, so with this thing, the problem with general structure is that if we have items, if we try to track the length of our this data, like length of rating, we have these many values, like it's like 39 lakh. We have 39 lakh rows. So if we want to create a 2D plot for that, if we want to create a 2D structure for that, and if we want to check exactly which one will like what, so there will be a lot of movies and a lot of structure that we have to fill in up. So it will not be a feasible way of putting up these values from where we get these data sets. So for you, this is inside our data sets folder. You can get it from there, and I got it from Kaggle. So you can even look for the anime recommendation system data set on the Kaggle, and you will find that. Okay, so generally the database is available on Kaggle, so you can take a look at Kaggle for most of the things. It will most of the you will get the right answer. Okay, so that is the thing. This is the basic structure. We will not go in very depth for the a lot of things, but probably you will have a basic idea now how exactly things happen and how exactly a recommendation system is built. Okay, so that is it for today. I hope you would have liked the session. And there is one thing that we are coming up with, and that is I code for slogan. So I generally will suggest you guys that to keep up the entho high, you can use on different platform. You can use iCode for and whatever you want to put. So like this hashtag I code for obviously there's no space. So I code for cause, and generally the complete tweet can be go like I code for education, I code for cause, I code for health, I code for cause, I code for betterment of society, I code for cause. So these kind of thing you can do, and we guys will be putting up with swags and some goodies for that as well. So we'll be putting up some posts around that, and that will create a good anthem. Yeah, face swap. Yeah, face swap. We will create a video on that. But I said that that will happen, based on your comment on the previous video. So if you want me to make video on that, so you can do that. Make a comment, and if you want to put more comments on that, so that we get more emphasis, what exactly you guys want, you can even ask your friends to request face swap on the previous video. So that's it for today. So for myself, it is I code for education, I code for cause. Kunal,
I code for the community's empowerment.
and I code for cause. Yay!
Yay. Uh,
Yay.
that was it about today. And then our next webinar is tomorrow, where we'll be doing a Q&A with a Microsoft intern. And after that, we have a boot camp on again Tuesday, same time, 7 p.m. We'll be doing linear regression and a housing problem. So yeah, it's gonna be fun.
Bye.
Bye. See you all tomorrow and then on Tuesday.